All right, so we've now completed the first ring of our diagram for 360 degrees. The finished diagram has 30 rings in total, and on the last ring of that diagram, we're going to be able to plot 360 points on the circumference of that particular circle. But here we're still on the first ring, and we're just going to look a little more closely at the geometry contained within its dimensions. So you can see that I've put a circle around each pair of smaller circles. So I've created geometric shapes that look like this. So we're just going to look at these a little more closely. You can see that the diameter of these circles is 4 times 0.5 root 2, because that's the growth pattern of our dodecagon. The very first ring of the dodecagon was built in units of 0.5 root 2. Then the second ring is in units 2 times that, then 3 times that, then 4 times that. So that section of dodecagon that's perpendicular to the 45-degree line is a length of 1.8 root 2. And then these two black circles have the diameter of 0.96 root 2. So half of that, their radius, is that divided by 2, which gives us a length of 0.49 root 2. So when we subtract 0.49 from 0.5, we get an answer of 0.03 root 2. Again, it's base 12 calculations. So that's the gap, 0.03 root 2 on either side of this circle, the distance between the circumference of the black circle and the circumference of the white circle. And then the gap between the two circles is going to be 2 times 0.03 root 2, so that's 0.06 root 2. So again, when we add up 2 times 0.96, the diameter of these two circles, plus all 4 of those 0.03 root 2 gaps, 4 times 0.03 is 0.1. 1.8 subtract 1.7 is 0.1, so we can see it all adds up to a diameter of 1.8 root 2 for this particular circle. So these are the units of circumference that we're going to build our complete diagram for 360 degrees with. They're going to be always making up the pattern on the outside. So this is the circle that's sitting directly on the point where the 45-degree line is intersecting our dodecagon, and then these smaller circles are sitting just outside. We always find that length by traveling along the 45-degree line, and then at a right angle, go the distance of 0.5, and then we use those points to define our second circle. So that's the basic procedure that we're going to go through for each ring of the diagram.